Okay guys, now we are going to get some practice with the DFAs. Yeah, we will look at examples. So in this and the next video, we will do that. In this video, we will look at DFAs and we'll try to figure out what's the recognized language and describe this recognized language. And in the next video, we will do the opposite. We will look at descriptions of languages and we will try to construct a DFA that recognizes that language. So we practice both directions. Okay, so let's start simple with the first example. Okay, so here it is. You see, first example, really simple, just one state. Yeah. I would actually recommend, as soon as you see the automaton, you should pause the video and think about think by yourself, what is the language recognized by this? And then, well, when you're done, you can unpause and then I will give the explanation. Okay, so you can pause now. Okay, now I give the explanation. So we see we have one state. It's an accepting state. And it has, the alphabet is ABC. That we see that because there are an A, a B, and a C arrow going out of this state. Well, and whatever word we read, we will always stay in this state, and this is always accepting. So we will accept every word that you can make of these three letters. Yeah, and this is the way how you denote that, ABC in curly brackets and then a star. Star means all finite combinations of these words, even the empty word, yeah? The empty word is also accepted because if we read the empty word, okay, we start here and then we're already finished. So we're in this state. And this is accepting, yeah? So this is the language recognized by this finite automaton. Okay, next example. Okay, here it is. As you see, still very easy. Don't worry, we will get to more complicated examples very soon. So think about it for a moment. What language is recognized by this finite automaton? Okay, it's very similar to this automaton. We will always stay in this state, but this time the state is not accepting. Actually, this machine has no accepting state at all, so we cannot accept any word. Yeah. So this means the language recognized by this automaton is empty. It's the empty language, or also called the empty set, because languages are just sets of strings, and this is the empty set, which is denoted usually by this symbol, yeah, a circle with a line through it. Yeah, and be sure not to confuse this with the empty word. The empty word is a word, yeah, but this is a set of words. It's the empty set that doesn't even contain the empty word, yeah. This contains nothing. We could also write it as like an opening bracket and a closing bracket. Yeah, this is another way to write the empty set. So this is the language recognized here. Okay, and here's the next automaton. If you want to think about it, pause the video now. Okay, so here we have two states. Yeah, this is not accepting, like we could say rejecting, and this is accepting. And we see whenever we read an A, we switch the state, and whenever we read a B, we stay in the same state. Yeah, so as long as we only read B's, if our word consists only of B's, we will reject. But if we have one A, we will accept. Yeah, and even if we have more B's after that, doesn't matter, we will still accept. If we have two A's in the word, then we will be in this state again, and we will reject. But if we have three A's, we will accept again, and so on. Yeah, so you see the pattern. With one A, we accept words with one A, or with 3 A's, or with 5 A's, or 7 A's. So we will accept words with an odd number of A's. Yeah, and actually we will accept all such words. Yeah, so every word that has, like every word made of A's and B's, that has precisely an odd number of A's will be accepted. Yeah, because then we will always land here. Yeah, so we could write it in the following way. The words W made from A's and B's, so from A, B star, such that W has an odd number of A's. Okay, and here's the next example. look at this finite automaton and think, what language does it accept? Okay, I hope you thought about it, and I hope you came to the conclusion that this is not a DFA. Yeah, we see that we have an A arrow here, we have a B arrow here, so the alphabet should contain A and B. Yeah, but from this state there is no outgoing B arrow, so this is not even a DFA. So that's what you should say if you see this finite automaton. You should say this is not a DFA. Yeah. Okay, so let me fix it, and then you can guess again. Okay, now I completed it. I introduced another state, and now it's really a DFA. Every state has an outgoing A arrow and an outgoing B arrow. So yeah, think a moment about what language is recognized by this DFA. Okay, here it's the first time the case that we have two accepting states, yeah? And whenever you have several accepting states, how you can figure out what is the language recognized, try to figure out for every single accepting state how to get to there, like which words do you bring into this accepting state. Like do it for every accepting state individually, and in the end you join all the words together. Yeah, so we will see in a moment what that means. So let's look at this accepting state first. Which words will bring you into this accepting state? The answer is it's only the empty word. Yeah, only the empty word. Like the empty word will bring you to here. Of course, it's the starting state, and if the word is already over, then you are here and we are accepting. And we see whenever we read any symbol, we leave the state and we can never come back because there are no arrows pointing towards this state. So it's actually only the empty word that is accepted by this state here. So let's remember the empty word for now. And now let's think how to get to this state here. So to get to this state, we need to take this way here and here. Yeah, we need to read an A first, and then we need to read a B, and then we're in this state. And then actually whatever we read, it doesn't matter anymore. As if we are here once, then we will be here forever. So if the word starts with A, B, then we will accept it, and we will accept it in this state. Yeah. So this state accepts all the words that start with A, B. Yeah, so you can write it like this: the set of strings W from A, B star, such that W starts with A, B. Okay, but now what is the language accepted by this whole automaton? Well, epsilon, the empty word, gets accepted, and also all these words that start with A, B get accepted. Yeah. So in total, we accept the union of these two sets. Yeah, and the union will be usually written with this kind of half circle. Yeah, so L is the union of epsilon and this language. Yeah, to make it more clear, I reorganized a little. Yeah, you just write this half circle between the sets that you are uniting. Yeah, and then this means the set that consists of this, of epsilon, and of all these words, all together in one set. And before we continue with the last example for this video, I just want to tell you that you can think of these different states of DFAs as like every state having its own purpose somehow. Yeah, every state remembers some information about the word that we've read so far. Yeah, so let's look at this automaton again. So this state remembers that we haven't read any symbol yet, yeah, because only the empty word brings us to here, and as soon as we read any symbol, we leave the state. So if we are here, we can be sure that we are still at the start of the word. Yeah. Then if we read an A, we go to here, and that's the only way how to get to this state. Yeah. So if we are in this state, we know we have read one A so far and nothing else, no B's, and only one A so far. Yeah. So that's what this state remembers. And then if we are in this state, well, we get to here if we read A, B, and also if we read another sequence of symbols, any symbols. Yeah. So this state remembers the word started with A, B. And this was also an accepting condition. Yeah. And so what does this state here remember? Well, we get to there if we read a B immediately. So it would remember either the word started with a B or it started with AA, because that's the other possibility how to get to this state. Yeah. So if the word starts with a B or with AA, then we get to here and we reject. And yeah, this is what this state remembers. Yeah, in this kind of state here on the bottom left, it's also often called a trash state, because it is rejecting and all the arrows that are outgoing point to itself. Yeah. So if we are once in this state, we will reject the word for sure. So the word that we are reading is already trash, basically. Yeah, it's just another way how you can think about the DFAs that might be helpful. Okay, so now let's look at our last example for today. We have this DFA, so think a moment about what language does this DFA recognize. So this time we have 3 accepting states and only 1 rejecting state. So maybe it might be easier to think, how do we get into the rejecting state and then do the complement in the end? Yeah, like we try to describe the words that bring us to here, and then we think, okay, what's the opposite? What doesn't bring us to here? Okay, so how do we get to here? Well, we see this is a circle, it's directed, we always go clockwise around, yeah. If we read 1, 2 symbols, then we're here, and then we have the possibility to go to here to reject if we read a B. So the first 2 symbols that we read don't matter at all. We will definitely, after the first symbol, we will be here. After the second symbol, we will be here. And if the third symbol is a B, we will reject. If it's not a B, if it's an A, we will go to here again. Yeah. So then we will also be here if we have read 3 symbols. If we have read 4 symbols, we're here. If we have 5 symbols, we're here again. And if the 6th one is a B, we will also reject. Yeah. If the 6th one was an A again, then, well, 7, 8, 9. So if the 9th one is a B, we would reject. Yeah. So you see the pattern here. If the 3rd is a B, we reject. If the 6th is a B, we reject. If the 9th is a B, we reject. So then the opposite, like this is how we reject, but we want to know the opposite. We want to know, when do we accept a word? Yeah. Well, we accept if the 3rd, the 6th, the 9th, the 12th, and so on, all these letters are A's. If all these letters are A's, then we accept. Yeah, and this is a way to write that down. Actually, I had to think a little what's a good way to write it down. So it's the strings W from AB star such that the nth letter or the nth symbol of W is an A. But for which n? Well, for all n that are a multiple of 3. And of course, they have to be in the range of the word. So 1 is less or equal to n is less or equal to the length of W. This is a new notation. I didn't use it before. It's the length of the word. Yeah. Exactly like you denote the absolute value of a number, we denote the length of a string, the length of a word, because we have to add this just to be a little more clear, because it doesn't make sense to speak of the, let's say, 12th letter of a word that has only 5 letters or something. Yeah. So if our word has 5 letters, then this condition only talks about the 3rd letter. Yeah. And if the word has 7 letters, then this condition talks about the 3rd and the 6th letter. Yeah. Okay. So that's it for this video. And in the next one, we will do the opposite. We will start with descriptions of languages like this here, and we will try to construct a DFA that recognizes these languages.